Thank you very much. We are very excited to present this workshop to you today. It's a bit of an experiment in and of itself. We have a vast body of knowledge to cover, and we've kind of distilled that down to what we think are the fundamentals for what you as software engineers will need to know. As Penelope said, this is a very interactive workshop, so we're going to kind of have you turn and chat with people in your groups, and then we have Daniela and Ty will be running some microphones around at the outset. So I wanted to kind of start off by getting a sense of who is in the room, and we do have to do this little dance of not getting close to each other. So, is anyone who in this room is a on-call engineer, a site reliability engineer? Okay.
Well, raise your hand if you've ever been on call. This will work. This is going to work. It's fine if you haven't been on call. That's totally cool. Just want to get a sense.
Do we have any marketing, product folks, customer folks in the room? One? Good. You are a representative voice too? Okay. Excellent. All right. Sweet. Well, let's get into it. So, who are we? So I am a researcher with Jelly.io, and I've been working in high-risk, high-consequence industries for most of the last 15 years. And my interest in software came about during my doctoral program at The Ohio State University. And I'd come from an industry where things are very dramatic. There's a lot of high speed. There's a lot of high pressure. There's a lot of adventure in the industries that I worked in. And when I was first told I was working in software, I was like, what, really? And then, as I started to get more and more involved in understanding what and how you do, I realized this is actually the quintessential occupation to really understand cognitive work and to really understand what we're going to talk about here today, joint cognitive systems. So we're going to pull in a number of examples from different industries and kind of draw that through line for you.
My name is John Allspaw, and like Laura mentioned, I got enamored about seeing connections between what we all do. My background is in software. I come from, I would say, infrastructural bent in my early career. I worked in a bunch of different places. None of that background really is interesting, so I don't want to spend too much time on it. The thing that's important that I want to get across is that talks like workshops like this, talks that hit on similar types of themes is all part of what I am pretty confident is perhaps a slower than we would like perspective shift in the industry. What we're going to be talking about today is it's so close to what you all experience that we sometimes don't really pay much attention to it because we are so good at it. I'll sort of describe that later.
Yeah, and I think one thing that we should also mention, just to follow on in that, is that we met at Lund University in the Human Factors and Systems Safety Design program. And I was really struck by the similarities between the work that I was doing and the things that John was seeing in the software world. And so that was almost 10 years ago. And we are both still continually learning. We're continually surprised by what we find when we actually look closely at people doing real work in real world contexts. It's amazingly sophisticated and it's fascinating, but it is a long journey. And so our goals with what we want to accomplish here today is we are, in essence, coaches here. And just as if you were to spend 2 hours on the pitch, you might know some of the movements, you might know some of the plays, but you're not going to bend it like Beckham necessarily. So we want to kind of set that expectation right off the bat, that what we're doing here is we're going to challenge some of the paradigms, some of the ways that you've been thinking about how you develop technology, how do you deploy it into fields of practice, how do your users interact with it, how do you interact with the tools that you have. And so at the end of the day here, we hope that you walk away with questions, you walk away with a lot of interest in kind of pursuing this further.
Yeah, this is, as Laura mentioned, this is an experiment. I mean, we have 2 hours. We're going to talk about a core concept that is, that touches every part of an entire field of engineering, one that also is not very well known. So the bar's pretty high. Again, if you're interested, there's something paradoxical. If we do our job here and you all are into it, you might actually leave somewhat disappointed or slightly unsatisfying in that you will want to know more because we simply can't get to it. That's still a win, though, for us, I think.
And so one of the things that I would actually correct about what you just said is like a field of engineering. But we're going to talk about multiple sort of interacting kind of fields, some of which you may have heard of, some of which you haven't. And when we were talking about like, well, how many people in the room actually know what resilience engineering is or have heard the term resilience engineering? Okay, yeah, you've probably seen some of it on Twitter. You might have heard some talks at different conferences. So what we're gonna break down for you is kind of these connections between these different fields and how they relate to software engineering. And so as we were talking about this, we were like, how do we make this connection for people without getting into this nerdy academic talk? And John had a really good example.
Yeah. So see this green bit here, this smaller circle, joint cognitive systems. This is like a core idea. Everything within the multidisciplinary field of cognitive systems engineering relates and connects to it. Think of it a little bit like this. If you're at all familiar or even not, but have heard of the field of statistics, right? Think of statistics, is it all about normal distributions and averages and mode and median and all that sort of thing? No, it's not all of it, but it's certainly a core part of it, right? It would be very weird to talk about statistics without having that as a bit of a framing. So think about it a little bit like that. The thing is that this workshop isn't on cognitive systems engineering, because frankly, we don't have time, and Laura just spent a dissertation on it. So we're going to just focus on this little bit, okay? Does that make sense?
Yeah, so we wanted to do a little bit of like bottom line up front for you here. And so at a very high level, these are the core concepts that we're going to talk about. The first one is that all work is cognitive work. So we're going to kind of break this down a little bit more, but we're going to talk about what does it mean to perceive change in events in your world? What does it mean to make sense of those? How do you assess the meaning and implications of that change as it's happening in your world? The second core point is that work is always distributed across different agents. And so here in the joint cognitive systems world, we're going to be talking predominantly about how you share this cognitive work, this thinking with both machine agents and human agents. And so when I talk about machines, I kind of use that interchangeably, talking about automation or a number of different kind of like artificial intelligence. So we're getting a little hand wavy with that. But that's the level of analysis that we're looking at there. The third piece is that these machine coworkers can actually kind of be jerks sometimes. They don't always help you. They don't always support you in ways that can either be slightly frustrating or they can be catastrophic. And the last one is that we actually can design and develop these systems of work for greater safety, greater productivity, and overall more resilient and robust systems.
So I think we're at a disadvantage because I didn't manage to get the computer to make the next slides on our presenter notes. So I have no idea what's going to come next.
We wanted this to be an interactive workshop. So we've got a series of exercises throughout the session, and we want to start with this, with understanding what is a joint cognitive system.
Right. So I want you to imagine, okay, that it's the end of your day, and the dog's been taken for a walk, or you finished dinner, whatever you do in your your routine, and you're ready to settle down and go to bed, and you get an alert of some sort. And so
You get a page.
You get a page, and you go to look at it, and it looks something like this. Okay, so what we want to do, I want to ask you a question, but before we do that, I want to see if you'll humor us here. We've got 3 exercises in this, and it would be great if we could maybe sort of come up with, maybe 2 tables for a group, or 2 tables for a group.
I think just turning around
turn
and working
around.
with the group behind you.
Right?
Yeah.
And so that would mean we'd have 1, 2, 3, 4, 5, 6, so a lot of groups. And so I'm going to ask you to spend a couple minutes on this question. And the question is, you get this page alert, okay? What do you think you would do next? That's it. Granted, you have, there's lots in here. We want you to talk with your neighbors about things that might occur to you in this hypothetical world that you would do next, given that you've just gotten this, okay? So spend 2 minutes talking anything that comes to mind. So it sounds like y'all have, sounds like you've got some things to talk about. Of course, you might be saying, I don't know what the hell is happening, or what the story is here. How do we want to do this? Do we want to have...
So what we'll do is we will, Daniela and Ty, front and the back of the room, if you've got something to say, raise your hand and they will run over. We'll give them a bit of a workout. So what would you do next?
What's an idea that's come to you?
And a brave soul in the back for the first.
I'd check for urgency. How quickly has this become a problem? How quickly is it going to become a bigger problem?
Well, can I ask you just real quick, how do you check for urgency?
Well, hopefully I've got something that's got charts that show me how much free space or other issues.
Excellent, excellent. Okay, super. What else? Any other ideas?
Maybe ping DevOps and go back to sleep.
Excellent.
Legit. We got someone in the back there.
I would ask, why are we getting this notification at 99% and not sooner?
Interesting.
I'd probably recalibrate that.
Yeah?
Yeah. Yeah, that's never been
What
a thing
else?
where you're like, why is this not working?
We said that historical context might matter, like if we'd seen this alert before and knew what it was versus if it was a brand new alert, we'd react differently.
Yes, yes.
Okay, so you have a sense
Excellent.
of what nominal and off nominal is? Betsy?
One thing I found kind of scary was the warning to warning transition. Another member of my group pointed that out because that means that we don't actually know if it's been going for 2 minutes or for much longer.
Yeah, I see a connection between that and what a couple of other folks have said as well.
I actually thought the same thing because state is now warning and also was warning, which either means this is a thing we don't care enough to do anything about and we're just ignoring these warnings, or someone's been ignoring it for too long.
Okay, so do you go back to bed?
All right, this is, thank you. One more, anybody else?
I'd probably log into Web 121 and actually make sure it's not a false positive.
All right.
Okay, some forms of verification, yeah.
Yeah. So this is excellent. They won. They did all of the
Yeah.
A+.
So,
Go ahead.
yeah, nicely done. So I have a question for you. So if this was your human coworker who phoned you up in the middle of the night and just told you this and then hung up, how happy would you be with them? So, yeah, boo. So this is fundamentally what we're talking about when we talk about joint cognitive systems. Is your coworker, is your colleague, your machine colleague, you know, kind of underperforming and doing things that are just kind of mildly irritating like this, like under-specifying what the urgency is, whether it's important, whether this has happened before. Sometimes they're just like, they're hard to collaborate with. It's frustrating, it gets like confusing, and it adds a whole bunch of extra work to try and sort out what's going on. And sometimes the consequences of having a really bad team player or a really poor coworker are deadly. So this stuff matters, and it matters in a way that is increasing. As we increase the speed and the scale of critical digital infrastructure, we move more of society's core functions into the cloud and onto digital infrastructure. This stuff really matters. It's not just frustrating. So here's where we're going to go. We've already gone through one of the exercises. Nice work. John's going to talk a little bit about like where did this thinking come from and give you a bit of the background. There's 40 years of literature and of studies going on in these other high-risk, high-consequence type domains, and that's where we're drawing a lot of this theory and a lot of this knowledge from. We're going to deep dive into what is cognitive work so that we can kind of break that down a little bit more and understand how it is distributed across a joint cognitive system. We're going to do another little exercise there, and then we'll kind of walk into if we have one machine, one human, is that a different interaction than many machines, many humans? Spoiler alert, it is. And then we'll get you to do a little bit of an activity there, trying to understand, like, how do we think about distributed cognition in these kinds of scenarios?
All right, so here it is. I'm about to do an extremely abbreviated and cherry-picked history that starts around World War II to where we are now. Ready? So, I'm going to tell you a very, very quick story. And so maybe some of you have already heard some of this. So, 1943, the U.S. Army was, like a lot of, not just militaries, but lots of large multinational organizations, it was all the rage back then that this idea, this notion, this stance that you could hire people, and in the process of hiring them and interviewing them, you could work out what they're good at, and then put them in a role where you could do it, right? It was seen as a problem of selection. You would take some like competency framework. People are like this, then you could do this, and people like that, you could do this. You would fit the person to the job. Here's the issue. What you see here is a B-17. At the time, the most like advanced military apparatus that had ever really been perceived, and it was brand new. It was known as the Flying Fortress. Here's the issue: in '43, what would happen? They would keep crashing, and I don't mean crashing as in like they go out to battle and then they got shot down, or they would go off to battle, and these like amazingly sophisticated machines would be flown back. They would land on the runway, and everybody's almost home, and halfway down the runway, the landing gears would be retracted, and they would belly flop onto the thing. Sometimes with bombs still on board. And so this seems to have been an issue. And it was happening with enough frequency that the Army was like, okay, this is a big deal, what's going on? It can't be the planes, because they're amazing, and they are very sophisticated. It must be something about the pilots. And so, for example, like, I'll show you a picture of what these look like. So they went to find this, in my opinion, very handsome, sort of somewhat Hollywood-style looking dude. One of the first psychologists, engineering psychologists as they called them back then, Alphonse Chapanis, and basically they brought him in to ostensibly figure out what was psychologically wrong with the pilots. And they said, because they thought they had a recruiting problem, Dr. Chapanis, please help us work this out. And so he shows up at the base and he says, oh, okay, doctor, we've got all of the pilots here. You can go and interview and talk to them. He says, okay, but before we do that, certainly I want to talk with them. Where do they work? Show me where they work. And so they bring him to a cockpit. By the way, this is B-17. This is how hardcore these things are. This landed and everybody was fine. Like it was a big deal. The Volvo of, I don't know, whatever, right? And so like, again, can't be something wrong with the plane. So he was like, this doesn't really make sense. And so they brought him, and they brought him. Here's the B-17 cockpit. And what I pointed out here, he noticed this. So the flap control, the thing that you put into place, you activate the flaps to slow the plane down, right next to the landing gear control. And they said, well, where's the other? And there was one other plane, the P-47. It was in service a lot longer. And he said, all right, and he noticed something about this. They're nowhere near each other. They're different colors. They're a different shape. And as it turned out, as you might imagine, you see where I'm going, is that a lot, if not a majority, of those accidental belly flops happened from pilots who had previously flown the P-47 and were adjusting new to the B-17. It's not that only B-17 pilots did it, but it was certainly something of interest. And so what this brought was, to this day, if you're walking past, you take a flight, you walk in past, you take a look in there, both an Airbus and Boeing aircraft, you'll notice that the flap controls feel like a flap. The landing gear feels like a wheel, and they're not really next to each other, right? This is still in place now. So the idea here is sort of quite succinctly summed up by what James Reason said, which is that we can't change the human condition, but we can change the conditions under which humans work. This was pretty mind-blowing at the time. The idea that you could design the environment of work, the stuff, the tools that people are using in such a way where it's less likely for them to make a mistake, rather than let's pour all our effort into figuring out which of the pilots are accident-prone and try to fix them. Sounds weird and pretty basic now, but it was really fundamental. And so this kept, as soon as that happened, this is what I just told you is, some would say maybe the origin story of the field of human factors. A couple things came from this, and it spanned throughout the following decades. The first was safety can be encoded in the design of technology, that accidents can be avoided by having more automation, that procedures can be specified to be objective and completely specified, and that operators just have to follow the procedures to get the work done. The joke, of course, in aviation, sometimes in nuclear power, was what does it take to run a aircraft carrier? Well, a dog and a human. The human is there to feed the dog, and the dog is there to make sure the human doesn't touch anything, right? And it's the joke that goes with this. So this notion was that you could come up with this like a bit of a framework that, look, humans are better at these things, and machines are better at these other things. Sometimes we call that habba-mabba. And this persisted. Here's this idea. Paul Fitz, 1947, literally wrote this out, right? You might find something familiar in this. Here are all the things that humans surpass machines in these abilities. And likewise, the machines surpass humans in these abilities. So this idea that you take these, use this to guide how you set up the work environments and design things, sounds pretty intuitive. It feels like, this was known as functional allocation. You do this part, and I'll do this part. So this lasted for a while. Lasted until roughly around March 28th, 1979 is oddly specific. Those of you who have ever heard of the accident at 3 Mile Island might not know that it was so seminal in the world of human factors that it completely flipped upside down how we understood people made decisions and how they did their work. I'm not going to go into the accident because we don't have enough time, but this was a seminal watershed moment. This flipped all of the things that I pointed out earlier. A good number of them either turned out not to be true or needed a lot of adjustment. So these new beliefs, the 3 Mile Island and subsequent accidents later, was that it revealed that when it comes to safety and cognitive work, automation is necessary, but also introduces new forms of challenges and risk. It doesn't come for free. Second is that rules and procedures are always underspecified. Raise your hand if where you work, there's some sort, you have run books on your wiki. Okay. Raise your hand if you think you could find right now one of those run books where if you followed it exactly to the letter, skipping nothing, you're going to have a bad time. Exactly. So the idea is that these procedures cannot guarantee safety by themselves. They have to be interpreted in the local context. Events in these environments will require people to make decisions and take action that can't be set ahead a priori, put ahead, right? So therefore, they're going to need support, foreshadowing. So methods and models for risk rely on human error categories, accounting, blah, 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 blah. Scientific word for this is horseshit. It doesn't really work. Sounds really intuitive, but it doesn't work. And that linear models of accidents, dominoes falling down, linear chains, blah, 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 also don't work. So this brings us to this notion. In the mid-'80s, a number of different folks came together and talked about this in the wake of 3 Mile Island, about all of these topics that we've got thus far. One of these ideas is the concept of a joint cognitive system. In the kernel of this are two perspectives. The first is that people using technology, you all, have a model, a mental model of the technical system, whatever that is, right? Whatever, all of the bucket of descriptors, applications, and infrastructure, and architectures, and blah, 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 right? You have a mental model of how it works, what it can do, what it can't do, what it looks like when it's broken, that sort of thing. You have this story, a mental model. Likewise, the technical system can also be said to have an image of you. It has an image of what you might need, of what you might use, or know about how it is to be used and how it can't be used, right? This is the key part. This is the perspective shift, right? So this is sort of the gist. This brings us up to where we are. The history's sort of over.
Kinda. I mean, it brings us to where we are today, but I have a little bit of a beef with kind of how this gets presented, because I wouldn't be standing here today if everything after 3 Mile Island was based on these new views of safety. We have a lot of legacy, a lot of leftover residue of these old models of how we think about safety and risk in the workplace. So as a researcher who's kind of studied this domain for much of the last 5 years, like, I have opinions about where the industry is at and where it's going and how quickly it's going there. But I'm actually curious about, for those of you in the room, where you think your organization is at relative to some of the concepts that John just talked about. So show of hands, how many of you believe that your company believes that accidents can be avoided by having more automation? Okay, kind of maybe a few on the fence there, not too sure. How many feel like your company thinks that it's necessary, but it also introduces new forms of challenges and risks? That's great. That's really inspiring to see. How about your company believes that you can put everything in runbooks, if your documentation is up to date, there'll be no problems?
I want to talk to you later on, man.
Remember, this is your company's view, not your view. I know everybody in here probably realizes that's not true. And how about like that rules and procedures are always underspecified, and so therefore, when you're in a local situation, you have to interpret those. Yeah, it's the old, it depends, right? What about engineers just have to follow the procedures to get the work done? How many organizations? Oh, nice. Okay, few in the back there. And what about that modern software operations require engineers to make decisions and take actions that can't be pre-specified? Nice, okay. So we have a lot of organizations in the room here who are like already thinking about this idea that you can have you can put structures in place to help guide actions, but those are not going to take you to the end of the road. At some point, an engineer or a collection of engineers are going to have to, they're going to face novel or unanticipated problems, and they're going to have to adapt in real time. Unfortunately, during service outages or during time-pressured situations, this becomes a really, it can become a very cognitively demanding situation. So when we talk about these kind of, where we're at today in the software industry, what we see from working with a number of different organizations is that these new ideas are taking hold. But as we can see in the room, those old ideas are still very much entrenched in our design, our development process, and yet what we see is that there's increasing complexity, increasing speeds, and increasing scales that these systems are running at. And so a lot of people had sort of asked me when I first got started in software engineering, like, what are you doing studying high risk, high consequence work? Like, software engineers, really? But technology is so inextricably linked to any kind of modern work world, and we're becoming increasingly dependent on relying on these systems to navigate much of society's critical infrastructure. And so we see examples again and again of really poor design and very poorly supported real-time sense-making, many of which have pretty profound implications both for the organizations that face them and as well for for society as a whole. So this stuff really matters. And even if you are only running an app that, say, generates random cat memes or something, which is objectively a public service, so I'm not calling it out here, we can still study the ways in which you as a software engineer interact with your technology, how you work in teams to keep that system up and running and continuously developing. So we can study and understand how joint cognitive systems actually work across the spectrum. So what do we actually mean by a joint cognitive system? A joint cognitive system takes a systems level view of people and technology in the real world. So one of the fundamental differences that John was sort of describing in how Chopinist looked at the world versus how kind of engineering psychology had taken place before then was he went out into the real world. He didn't study this in a lab environment. He didn't create these kind of toy problems and then test students or non-experts. He went out and looked at real world contexts. And so that is fundamental to joint cognitive systems. Instead of this humans are better at, machines are better at dichotomy, we look at what do machines need people for, and what do people need machines for? And so when we take that view, we say they both have cognitive capacities. Machines can do things at a larger scale, they can do them faster, they have capabilities that support and augment human cognition as well, but they lack context. They kind of fall down when they're outside of their prescribed for boundaries. And lastly, the unit of analysis, therefore, is that it's the cooperation between these agents in joint activity. And so this seems really self-evident that like, okay, yeah, you have to understand interactions. But when you start thinking about cognitive work being shared across two agents, it becomes less about, okay, you do this and then you tell me when you're done, and more about, do you provide the kinds of information that help me be ready and primed to take action, or do you leave me hanging in the example that we described earlier? And so the primary challenge of thinking about this concept of joint cognitive systems is, how do we make automation, how do we design automation to be better team players? So how many of you, while I was talking, were just like, wait a minute, this is user interface design or human-computer interaction? Show of hands. Oh, okay, only a few, perfect, all right. That's okay, that's legit, because they are related. Just as we were talking about earlier of kind of how joint cognitive systems is a concept that's nested within this broader body of cognitive systems engineering, we can also look at the ways in which user interface design, user experience design, and human-computer interaction kind of uses some of the concepts and sort of understands some of these same, shares some of these same kinds of perspectives, but they're limited in one really important way. And that's that they don't necessarily focus on the cognitive work that's inherent. They look at sort of task allocation, they might look at sort of optimizing the human in certain situations, but they're not necessarily thinking about like, what is the thinking that's taking place? So it's about time that we actually talked about what do we mean by cognitive work. So cognitive work, the cognitive functions that we have is basically how we stay alive in the world. We perceive if there's risks or threats in the world, and we adjust and change our behaviors to be able to avoid those risks or to minimize the impacts on us. We have different sort of priorities and goals that we want to achieve, but the world is always changing and doesn't always kind of provide the opportunities to enact those goals and priorities. So we have to continually be adjusting and shifting, reprioritizing relative to the demands on our time, the demands on our attention, or the changing demands of the environment around us. So fundamentally, when we think about cognitive work, it's asking the questions like, what is actually happening here? How much information do I have about the situation that's in front of me, which might be something as simple as, not that they are simple, but as building a new feature, or as kind of doing a migration. It may be something as complex as, our early example with the alert is this something that is going to eat my lunch and I need to deal with it right away? I think that's kind of a Canadian saying, actually, eat my lunch. It's about saying what should be happening. So I see what's happening in the world, I'm making sense of that, but is this what I expect to be going on at this point in time? Is this off my expectations? What does this actually mean for the goals that I'm trying to accomplish? Why is it happening in this way? Is this something that we have seen before? Is this deferred maintenance? Is this increased user volume that's expected? What's going to happen next? So this one's really fundamental when we start thinking about joint cognitive systems, because when you're designing that kind of shared cognitive effort, the ability to anticipate what's going to be appropriate action and how do we move forward in constructive ways is really important. And then, of course, someone mentioned trajectories. How quickly is this happening? How long has this been happening? Really understanding that what's happening across time is very fundamental to being able to act appropriately. And then, what options do I actually have here? And how can I prepare, and what resources, how can I actually cope with this situation as it's handling? So all of those functions that are coming up on the right-hand side of the screen there, observing, anticipating, recognizing change, replanning, reprioritizing, this is the stuff of cognitive work. This is how you make things happen in your job, in your day-to-day lives. So we've told you a little bit about what cognitive work is. We're going to go back to our exercise there and see if you can actually spot the cognitive work there as well.
All right, so let's go back to this. As an aside, by the way, has anybody recognized the structure? I'm mostly curious of this particular representation of an alert. For those of us who are old in the room, there used to be an alerting system called Nagios. And this is the default template for what disk space alert would have. This is the default. So we're going to do exactly what we did before, where you're going to talk amongst yourselves. I'm going to give you a different question here. And the question in this situation, this is the same alert, right, that we talked about before. What sort of things do you think you'd need in order to determine if you can confidently ignore this alert? Okay? What do you think you would need beyond what's here to know if you can dismiss this as noise or something I don't really need to get, I don't have to do anything about? Okay? So just take 2 or 3 minutes, talk amongst yourselves, and we're going to ask you what you came up with, okay? Have at it. All right, everybody. So let's see what y'all came up with, right? So I take it that all of you came up with amazing answers. Every one of you will tell. No, just kidding. Who wants to offer up an idea about what they would need in order to determine if this is an alert you could ignore?
Very, very basic, but what are we even using this disk space for?
Okay, all right. Excellent, excellent. That's a very good question.
Maybe the context. Has this occurred before? Like, say it occurs every day, or also how much space has been used over time? Is this a slow growth or a fast growth?
Yeah. So it sounds similar. Yeah, that's excellent. It sounds similar to reasonable answers for the first exercise as well. Yeah. Excellent. Who else?
Yeah, I guess what Web 121, what its like business purpose is, what it's fulfilling.
Okay. Yeah.
So you're thinking in terms of prioritization then? Yep, okay.
I guess just, is the disk continuing to be written to, or is it stopped? Is the writing stopped?
Yeah. Excellent. All right. So.
We got one more.
Oh yeah. One more.
Oh, 2 more. We got time for you both.
Need to understand what the last line is saying there. Are we running out of space in a volume or on the entire server? The megabyte number seems interesting. Seems like a lot of space is free, if I'm reading that right. And then the 9%, like where are we talking about?
Yeah. Excellent. Super.
Like, who's expected to resolve this alert? Is it expected to be resolved by a human, or is it expected to be resolved by some sort of automation that, is there a service monitoring this that will automatically up the disk space, and this is just letting us know about it?
Yeah, which may lead you to wonder, why are you even telling me? Right. Anybody else? Oh, this right over here.
What even is the threshold that we're crossing?
Yeah.
Is it low? Is it high? Are we above? Are we below?
Great.
Is this a production environment?
Excellent. Excellent. Yeah. All right. So look, I want to reflect a little bit back about what you've all, a number of comments, a number of directions that might be useful to help you understand, is this a big deal or whatever. I just want to point out the implicit expectation that no one questioned, which is alerts, you can get alerts that don't require anything because they're annoying, right? The other thing that struck me is a number of you made comments, and with the first exercise as well, about the content of the notification, right? A lot of you are like, I don't even know what this means, and I'm not entirely sure if it matters. Even the confusing, right? Notice it's disk warning, and then it reports free space, not used space. That's also a little bit strange. Is 9% what's left? And is inode equals 99? Is that important? I don't know what that looks like. Doesn't say anything else about that. Warning for what, right? Even if you were to go out on a limb and say like, oh, we've got warning, and then we've got critical, well, how far are we from critical? The second thing that others pointed out is that the fact that you got this notification, let's say you actually did understand, but you had no idea about what of the recent past, right? Has disk space been alerting all over the place recently? Has Web 121 been freaking out in not just disk space recently? Or is this alert come out of nowhere after no alert about disk space or from 121 has been seen in the wild for 2 years, whatever, right? And so there's content that's important, and you all know the fact that this is a terrible alert. And again, like Laura inferred later, if you were at work, let's say, imagine we all used to be in an office together, and you're typing away, and Lisa's next to you, and Lisa says, Web 121's disk space is in warning, and then went back to work. You'd be like, is she okay? You wouldn't do that. The exchanges you have are fluid. They're really quick, right? There's some expectation that you and Lisa have some sort of understanding. Let's say if you're getting the alert, like, oh yeah, Web 21's squawking again. Oh, is it data 01? Yeah, all right, I handle that, right? Those things are very fluid. So in this way, the alerting system and the content has a really terrible image of what's important for you, okay? I'm going to push you all here, given what we talked about in a couple slides ago, Laura walked us through cognitive, how would you describe the cognitive work, hypothesis for workshop sake, goes into dismissing or not dismissing? I'll throw out an idea here in that somebody mentioned, is this one of many in the recent past? So it turns out that memory has something to do with this, right? Temporality has something to do with this. Not just that you remember that Web 121 is particular or not particular or important or not important for some reason. It's in staging, it's in production. You have stuff, understandings, when you go to look at this, right? What else? You may have a picture in your mind about thresholds. Alerting, the most basic form of alerting, which has all sorts of pros and cons to it, are static threshold alerts, right? As somebody pointed out, I'll just put a more finer point on it. Did it go, let's say it did say that that warning is at 85% and critical is at 90%. What I heard from all of you in the last couple of exercises is, okay, one thing I'd want to know is, did it go from 20% to 85% in the last 5 minutes? Or has it been at 84.99% full for the last 3 years and just so happened to over it, right? That would matter. That would be different. You see what we're saying? So the cognitive work that you are doing can be hindered or helped by the design of the alert in and of itself.
And I think one of the important things that you mentioned was this idea that you can actually ask Lisa, like, what do you mean? You can ask Lisa some of these questions. So in CSE parlance or in joint cognitive systems, it's can you actually interrogate your coworker? Can you actually interact with them and extract new and different information that's going to help you in your sense-making process, help you in your ability to prioritize it, or to recruit and gather more people who might have different knowledge bases than you do?
You'll recognize some of these. This slide is just a pointer. Earl Wiener, in the early days of autopilot in aviation, ran a number of studies at NASA Ames in Mountain View, California. And after the pilots were done, the first time they'd ever encountered a autopilot, they would, recordings of them actually flying with autopilot doing some stuff, they said things like, what's it doing now? Why is it doing that? What will it do next? How did it get into the state? Have these questions ever occurred to you when you're working in your code? This is what we mean by cognitive work, and these are the connections between these other domains.
And that was 1989, by the way. We're still answering those questions.
Want to take this?
Or go for it. Yep.
Okay, so what makes a machine a team player? I'm going to give a little bit of a description now. I want you to imagine that alert earlier. Somebody I worked with a long time ago wrote like a plugin, I think, to help, in that case, Nagios, but insert Prometheus or whatever sort of alerting system. They're all terrible in their own ways. What he did was he would shadow people who were actually on call, and when they got a disk space alert, he would try to work out, talk with them, either wake up with them or the next day, what exactly the question I asked in the first, we asked in the first exercise. What do you think you would do next? And a lot of them gave the same answers. So he changed the content of the alert to include some pictorial graphic representation of the volume that's an issue, some amount of historical context. You'll note that this looks like it's just bumped over, right? Tells you what the threshold was, what the volume was amongst all of the mounted volumes, and how it has been, and the frequency of the past alert. Computer knows all this. You could help it you could help it help you by doing this. And this is an example of when we say context, everybody needs more context. Excellent. Question is, what context specifically? You'll note there's a whole bunch of stuff that's not included in here that you could imagine might be really helpful. You can't include all context, because then you'd have two problems. You'd be getting the alert, and now you have to navigate what the hell the alert's trying to tell you. You were already doing that before. But overload is also an issue. So this is an example, just one of many, I'm sure, almost certainly, and this is even a dated screenshot. This gets you a sense of what makes a machine a team player.
Yeah, so just to put a bit of a finer point on this, when we talk about the design characteristics of what makes a machine a team player is fundamentally that it is a cognitive aid. So all of the things that we were talking about is supporting your cognition, your sense-making, your ability to put these things into context. And so the machine needs to be designed and fielded in a way that supports your ability to make sense of things. Earlier, when I talked about kind of looking at the real world of work, some important considerations about what does it mean to be a cognitive aid includes things like, are you sitting in a quiet room with nothing else to do, just with your fingers on the keyboard ready to receive an alert? Most likely not. Your attention is distributed across multiple threads of activity. You might be in a Slack conversation, you might be in a meeting, you might be dealing with some other kind of customer request. So understanding, to John's point about this data scarcity versus data overload, is like, what information is important at what points in time to actually serve as an aid and not a hindrance to you. It supports functions, not just specific tasks. So it allows you to anticipate what might be useful next. It allows you to reprioritize, to say, this was important, but given new information, I need to drop some of these goals, or I need to like move up certain things over others. It supports human judgment and expertise. Again, we are some of the most complex and sophisticated cognitive agents on the planet that are able to work in real world conditions. And so supporting your judgment and your expertise, your ability to discern the right course of action from the wrong in any given situation is critical. And as we talked about with Lisa, that ability to be interrogated. Can you ask and answer, or does it help lead you to where more information for you to be able to answer those questions are? So it has affordances. So it has some sorts of implicit designs that show you how to use it, how to interact with it, and what the limitations of its capabilities may be. And it aids anomaly detection. So this is, many of you talked about when you were sort of identifying what you would need to know, whether or not this was something you could ignore or not, is this nominal, is this normal, is this expected for this given point in time or age of this aspect of the component? Whatever it is, it helps you to recognize when there's variability that's outside the expected thresholds that you might see. It aids with this rapid sense making. So we've been talking a lot about nuclear power, about aviation. A lot of these examples are drawn from healthcare. These are situations where seconds matter, microseconds matter. And so the fact that that information is not readily available to you at different points in time actually matters a whole lot. And it's related to that it's clear under conditions of time pressure, stress, and uncertainty. Again, if you are responsible for multiple concurrent activities at once, you don't want that cognitive agent continually asking you, like, are you looking at this? Did you think about this? Did you check this? You need to think about the coordination of those interactions as well, so that you have smooth transitions for when the machine takes over, when the automation is expected to step in, and when you are expected to sort of step out of that. So this is kind of this idea of supervisory control. So far, we have been talking about this one-to-one relationship. One person, one machine, but how many of you actually work alone or work in that fashion? Probably not very many of you, if any, because real world work or work in the modern world is about many people and many machines. So this is from a paper that, if you've been kind of interested in resilience engineering or cognitive systems engineering, you may have seen joint activity and common ground in joint activity and coordination. It's not to get all sort of like nerdy and prescriptive here, but they talk about this concept of joint activity, of this extended set of behaviors that's carried out by an ensemble of people who are coordinating with one another. And so joint activity is this activity that produces something that is a genuine joint effort. It's not just you do this and I'll do this in parallel and we meet together at the end. There is an element of it that requires you to interact over a span of time. And so that span of time could be anything from minutes, could be seconds. You have a brief interaction with a person or with a machine, or it could be days or months or years. So it kind of seems almost disingenuous to point out that any kind of modern work is joint activity, because this is the stuff this is the stuff of everyday work. But what's critical here is that we're pointing to this idea that coordination absolutely matters. We can't just leave this up to individuals individuals to kind of think about this as an afterthought. This has to be an essential part of how we design and deploy these into fields of practice. So what's important under this context is as well that all of this coordination actually has a cognitive cost. So we were talking about how seconds matter, how microseconds matter. Well, poor coordination requires you to be thinking more. It requires you to take extra steps and activities to be able to ensure that there's sort of that smooth transition across agents. And so so when we're talking about joint activity, we are talking about coordination. So another kind of element of what's really important when we start thinking about these joint cognitive systems is that different parties that are engaged have different goals and priorities. So they're going to have different interests and want to see things happen in different ways. And so a fundamental kind of takeaway is like, as humans, I can adapt and adjust my performance relative to John's goals or interests. I can say, okay, he wants to step in and do the slide in this way. I will take less time to do this slide. Or, yeah, it's really important to emphasize this point. We will adjust on the fly to be able to really, make this come across. But machines really struggle with this. They can't necessarily adjust and adapt their goals and priorities as the context change. So it kind of puts all of this additional effort to coordinate with machines onto the humans to be able to adjust their goals and priorities. So I'm going to use a really simple example of coordination in joint activity, and that is basically traffic. Because people in this situation, when you're driving, you kind of, not yet, you kind of know, you know how traffic works, right? There's an expectation of like one person goes, there's turn taking, you need to signal a little bit here and there. You need to anticipate your participation in this broader joint activity. This coordination is happening in real time. So in this example, people are slowing down, they're speeding up relative to how they anticipate the actions of those who are around them. They're signaling, if they need to cut across traffic. They're going to adjust relative to the flow of the situation around them. So I want you to think about what would it mean to put a self-driving car into this flow. What do you think would happen in that context?
Have anybody here ever found themselves responding to an outage? Some incident, right? Sometimes Laura and myself have spent a number of years studying in great detail what goes on. As a matter of fact, if you'd really like to read something mind-blowing, then you'd read Laura's dissertation on exactly that cost. Lots happen that we, as participants in that joint activity, do not explicitly acknowledge that we do. Right? That's the thing about having expertise, is that the more expertise you have, the harder it is for you to describe how you have that expertise. Understanding and identifying cognitive work in the wild is helping pull that apart. Sometimes when we see a response to an outage, it can be, in some organizations we've seen, really fluid. And I mean so fluid, multiple, 5, 6, 8 people all working almost entirely as if this is what they were born to do. And when you look at both Slack transcripts and Zoom calls, it sounds like this. Hey, yep, I saw it. What do you think? No, I'm going to check. I have that. You know what I think? No, I went, look, it's not that. You know what? Oh, yes, it is. Oh, I think, yeah, it's that. Should we, no, don't, no, not this time. We should probably do this other, right? Right, and of course, we're like, as cognitive systems engineers, we're like, awesome, right? The interviews practically write themselves. This is what we mean by distributed, sorry.
No, that's okay.
I improvised just now.
Yeah.
I can't tell you how I did it.
Yeah, what you're talking about is that smooth handoff, those smooth transitions, that flow. And so when we juxtapose, an example of this or what you were just describing with that earlier, example of the alert kind of dropping in out of nowhere, it's a really stark contrast. So we still have a lot of work to do.
So for this last exercise, right, we're gonna, unfortunately or fortunately, we're gonna return to the same example. And by the way, the alarm problem and all the paradoxes with what academically is described as directed attention has been a topic in cognitive systems engineering and human factors, for that matter, as a whole for decades, way before internet. So we're not special with this particular problem. So is this a joint activity? Anybody would like to ask or say yes or no? Yes? Okay. In what ways? Yeah. Oh, yeah.
Yeah, we've got a machine who's communicating to a human, and then the human then doing some cognitive work to figure out next steps and go probably to another machine and get more information.
Yes. Excellent. Anybody else? You nailed it, by the way. It's, of course. So, I want to, what's that? Yeah, go ahead.
So who's not represented in what you just said? Is there anyone not represented in that description?
How many people are on that escalation policy?
Ah, excellent. Nice.
Okay.
I was thinking customers or stakeholders or whoever might care about the system going down.
Yeah?
Yeah, absolutely. Anyone else?
The machines that's being alerted on in the first place.
Yeah. Say more about that.
I mean, presumably, it's an entire system of things, and the host Web 121 is a machine that is being alerted on, and presumably there's probably also all other kinds of monitoring that's taking place.
Yeah. Excellent. See, I told you they were going to get it.
We got one more at the back there.
Whoever designed the alerting system and had these logs spit out for this specific reason, the actual human who set it up.
Nailing it.
I feel like our work here is done.
Yeah. All right. Well, okay. So great. Let's go. Yes, all of you are right, and I think that's important. Before we get, so we're going to expand, I think, a little bit on that. That idea that what is and what is a joint cognitive system can be have multiple layers to it. I want to give a quick story from a place that I work with. This may or may not fit with those of you who have been on call in the past. So this organization that I work with in Brooklyn, New York, called Etsy, there was a period of time when the on-call engineers were struggled with, faced a bit of a quandary. So here's what would happen. What would happen is there are some bits of the infrastructure or the systems or whatever that, for whatever reason, might be more, it's more attractive to do maintenance on clusters or subsystems, whatever, at night, right? Or at night in whatever the particular time zone is. And like I said, it could be for a whole host of reasons. Sometimes maintenance would be done by somebody who wasn't on call at the time. Somebody else is on call, right? So, Stephanie's on call, and Stephanie lives in New York, and Stephanie's gone to bed, and Raj is going to work on this cluster ABC. And Raj is like, okay, I'm going to do this starting about 9 o'clock, and I think it's not that big of a deal, so I think it'll probably take an hour. So what would happen is Raj would go like take all these nodes out of service, out of production or whatever, and then silence the alerts, because he knows that like he's going to turn stuff off and on, and I'll doing a whole bunch of things to them, and then like once that's all done for however 50 bucks, 100 whatever nodes or whatever, then like put everything back and then get on, and then maybe he'd go to bed or something like that. But what he doesn't want to do, he doesn't want to wake up Stephanie. Stephanie might have had a really crappy week on call already. He definitely don't want to wake up to find out that like an alert slipped through, woke her up, but actually it's not that big of a deal, right? Because the alerting system doesn't know that it was out of production or something like that. Anyway, so what they did was, because what it would happen actually quite often, because I'll set downtime, so it's like a temporary silence the notification. The checks would still run, because you don't want to turn that off, because you might forget to turn them back on again. So you set a timer, so like, okay, for the next hour, don't actually send an alert. Still do the checks, but don't send an alert to somebody. And then like 45 minutes pass and 50 minutes pass, and Raj is like, all right, cool. This is gonna be done before the hour's up. And then something's weird, and like, ooh, okay, didn't think of this. Sticky problem, this last couple of nodes, ooh, so he's focused on getting this issue worked out. Meanwhile, and sure enough, page goes out because the hour flipped, and it's broken. Wakes up Stephanie, and Stephanie's like, Raj, what the fuck? And so they wanted to do this. So what they did was they built a little bit of a thing that said, okay, we're cron job or whatever, every minute or so, okay, what's been given temporary downtime? Okay, cluster ABC. Okay, is it less than 10 minutes before that downtime is supposed to expire? If yes, write the person who set the downtime, in this case Raj, and buzz the shit out of his pagers, like with an option inside the alert. Hey, Clippy style, it looks like you're about to have an expiration come downside, and you're about to be kind of an asshole to your teammates. Would you press here to extend the downtime? Sounds really simple, but it was an approach to solve a particular problem. Now, of course, this is extra code, which has an opportunity for extra bugs. That was just an example of a relatively straightforward thing that gives the alerting system just a bit, doesn't solve it, doesn't turn it into a human, just a little bit more of support, okay? So back to all of the ways that you could identify all of the actors here, agents, right? There's the alerting, there's a system that sends the alert. It might even be different than the system that's actually making the checks that fuel the alerts. There's the thing that's being checked, there's the receiver of it. Somebody else also said something along the lines of the on-call schedule. One of the ways that we can think of this is that layers of joint cognitive systems can actually broaden in directions that you might otherwise think are sort of outside the scope. Somebody had, when we did a dry run, somebody had mentioned, well, company, investors, I don't know. An example that comes to mind was, let's say, a security vulnerability. Security vulnerability, to some extent, a report, CVE, is a notification. I would argue that the investors, perhaps even board of directors of Equifax, all of a sudden are somehow interested in alerts. You can, but these opportunities to see joint cognitive systems in different areas and what cognitive work means in support of each other can broaden and vary on different scales.
Sounds good. I want to actually just put a little bookmark here to riff on something, because I think we're going to finish a little bit early. You brought up a lot of like disparate sort of stakeholders when you were talking about the joint activity. So I want to talk after we finish about what that means when we are learning from incidents, and like what does that mean when we distribute the sort of learnings about that? How can that enhance performance across a system? So I keep coming back to this point about like what, speed, scale, complexity, as all of those increase, the importance of designing these things more carefully becomes more critical. And so we're coming back to these because as researchers, as members of the community, we want to sort of turn this around to you as well. It's like these are practices, these are concepts, these are theories that can be applied in everyday work so that we learn and understand more about human and machine interactions, more about the real world of work and how these things actually play out when there's multiple competing goals and priorities, when there's time pressure, when you're under production pressure, because those same kinds of characteristics of your work world are inherent in a lot of very high hazard environments as well. So we need the designers and the developers of these systems that are being built today to be considering these demands of running these systems at speed and scale for purposes that they may not necessarily have been designed for, so that we're able to enhance the resilience and the safety within these systems. So we're kind of coming to the end of our time together here. And we've talked about a number of kind of characteristics about what makes machines good team players, about how to make your tools and think about your interactions as part of this larger joint cognitive systems. So we're kind of going to leave you not necessarily with specific takeaways, but rather with questions that you can use to inform and expand some of your existing practices and processes. So when we talk about making your tools part of a joint cognitive systems, it's important to consider the cognitive work that you are supporting. What functions are you expecting the automation to take care of? Oftentimes it's like, oh, that's toil, let's just make a machine do that. But are there aspects of conducting that work that help you make sense of and sort of keep the finger on the pulse of what's actually happening within that system? So if you automate it away, are you actually changing the nature of the cognitive work needed to make sense of that situation? So what functions do they support? Do you consider this across the joint cognitive system? Considering the joint activity. So you all were like, kind of blew my mind actually, how quickly you went into very disparate places with who's involved, who's related to this, maybe not directly, but also indirectly, who's impacted by some of these decisions and actions. And that is actually really fundamental, because the more the wider your sort of conception of how your system works, where pressures and constraints are coming from, what kinds of influences do different parts of the system have, the better you're able to anticipate certain kinds of problems and prematurely adjust your actions or adjust the way that you're conducting your work to be able to cope with any kinds of reverberations that might come out of a different part of the system. So who's involved? How do they interact? What kinds of impacts do we have on each other? And how will these handoffs between machines and humans safely take place? And lastly, what assumptions are you making about the nature of this work? So we've kind of implicitly been talking about this the whole time, is who's doing the work, what other kinds of work are they doing, how much time and attention do they have to allocate to different parts of the task that they're faced with. So we have some time here for question and answer, but we wanted to kind of turn this around to the group and hear a little bit. You know, at the outset we called this an experiment, and as we mentioned, this is like a big part of other domains that, you know, some of the examples that we've pointed to. We can't yet point to a lot of really good concrete examples in software. And so given that we as an industry, as software, hasn't had our 3-mile island to kind of shift the thinking within the industry, I'm curious about what it is that you think you might take away from some of the things that you heard today in order to change how you think about your work. It's a big question for the end of the workshop.
And I guess if there are questions that people have, still for us.
We'll take those. We got one at the back there, yeah. And there's one up here too.
Thank you. Right now I'm working with a lot of engineers, like material engineers, mechanical engineers. And my team is responsible for digitizing and scaling up a lot of what they're already doing manually, cognitively. And there's a real dichotomy. This cannot be automated. What we do is more of an art form than it is a science, but you need a lot of science to do it, and a machine will never do this. And on the other side, there's, you know, I can write that in a week and eliminate that need for this person forever. And what this really shows is to just completely change that assumption about this discussion and try to tap into both of them. And I think it'll make the conversations that we have at the startup a lot more productive. So thank you.
Oh, excellent.
Yes.
That's great.
Yeah.
It's so satisfying.
That's fantastic. And it is also, like, I think even that subtle shift, right? Because that dichotomy exists right now in a lot of these conversations is like, no, we can trust automation. We can, you know, we don't need humans for this. And so even that subtle shift of like, how might we be sharing this load? How might we be coordinating and handing off work across these agents is fundamental to so many conversations right now.
Hey, just had a question. So in the alert example, what if you're a company that's getting this alert from a third-party company and you can't change the content? What are your options to kind of reduce the cognitive work in that case?
Well, before I'm going to turn the question back to you in a second. But before I do that, certainly to aid the cognitive work, I'm not entirely sure we can reduce it, rather change it. The receiver of an alert will always be engaged in cognitive work. Whether it's, we tend to think of less cognitive work for easy things, but it's actually not less, it's just different. But the point that, back to the suggestion that, or the scenario that you put, it's a really good question. I maybe would ask, I would want to explore what the current situation, how do people currently handle that? Getting a work, like if you're getting an alert, then somebody's getting it. What do they do when they get it? They probably have workarounds. In fact, a significant amount of cognitive systems engineering work is discovering what workarounds people have. Do you want to say anything?
Yes, I do. It's a great question, actually. So my dissertation work, which John mentioned, was looking at coordination across sort of large-scale distributed systems. And what came out, like I was studying basically incident response teams. And what came out right away was that it's not just about the incident response team. It's about the vendors. It's about other teams whose services are dependent on that. So that it became very difficult to draw the boundaries around who owns what because they were so tightly interdependent. And so what you're describing to me is like a failure of one of the coordinative agents to really understand what it is that you need, you know, from your perspective. And so I agree with what you're saying in the sense of like being able to sort of describe some of this. It's hard to go to a vendor and be like, you should change this. But I think you can make a compelling case to be able to say, when we receive your alerts, you know, here's the information that we don't have. Here's what we have, like exactly the same process that we went through with these examples is like, here's what we lacked, here's the questions that we had, here's the steps that we took to kind of, you know, get more context for ourselves, and here's who was important at what points in time. And so I think like it's putting some of that work onto you to be able to describe that to the vendor, but you could also go back to them and sort of say like, hey, I think you need to look more closely at how these things are landing in the real context of work. As a, you know, a software vendor, a member of a small startup right now, that would be gold. Like that kind of interaction and collaboration shifts those boundaries about how do we think about who's responsible for the coordination. And it does become much more of a joint activity when you're sort of thinking about reciprocity, you're thinking about the work across the system. Does that make sense?
Sure.
Yeah.
Anybody else?
Betsy up front here.
So hypothetically, let's say that you're very bought in on all of the ideas presented in this talk, but that you're embedded in an environment that is perhaps a bit less so. What harm reduction techniques are available to you personally in that kind of situation?
Say more about that.
Yeah.
Yeah, sorry. I genuinely am speaking on behalf of a hypothetical person who I assume is in this room, let's get less hypothetical and talk about a situation that I'm not in anymore, but that I've definitely faced in my career. What if you've got alerts blaring all the time and someone who believes that the problem is the competence of the engineers rather than lack of slack in the system, for example? Like, what about other situations of that nature? How do you bottom up it?
I think it's like, it is fundamental to the work that we are doing, I think both like in a day-to-day tactical like sense in our work, but also as part of a broader paradigm shift within software. So I've seen a couple of like instantiations of this problem, which is like maybe not necessarily that the person is directly sort of in the line of fire of like, the machine can never be wrong. It's got to be something with you. I think that, you know, the same way I answered that question there is like being able to, actually let me pause on that. I was about to say like being able to sort of describe the complexities or describe some of the, and Betsy is doing a talk about storytelling and narrative later, which I'm very excited about because some of these things, when we talk about them in very theoretical, abstract terms, they, you know, it becomes an argument about whether machines are better or whether humans are better, and you lose all of the details about what makes this work hard, right? And so I paused there for a moment because I don't think it's inherently the engineer's responsibility to say, this is a complex world, there's lots of goal conflicts, like, you know, I'm assuming this is someone in a position of power or influence or authority, you know, have put certain kinds of pressures and constraints into the system that make it hard for me to take any other action than the one I took. I don't think that's necessarily the role of the individual engineer, but I do think that there are sort of like guerrilla ways to surface some of these things in everyday work. Mm-hmm. One of the things that the sort of bookmark thing that I wanted to talk about was like incidents as an example, as an opportunity to surface normal work, to surface that this stuff is not, it's not the exception, it's the rule, that you are always facing these kinds of conflicts in your day-to-day work. And so I think that's one example of an opportunity to like not go down the root cause analysis hole and say like, oh yeah, it was just this, but rather to say, whoa, let's step back and look at all of the like, both the human and the technical like factors that were involved in this incident, because it helps you understand how your system actually works and how it actually performs. So while I said I wasn't going to leave it on the individual engineer, I would say both like, you know, in that example of you being able to sort of see the water that you're swimming in and point it out and say like, this is extra effort. The coordination, the cognition, this is extra effort in these ways can be useful, and as well using structures within your sort of organization to be able to kind of put some more of these things on the table so that it's not just a heavy lift for one person. Mm-hmm. Did you have anything you want to add to that?
No. Other than try not to think of you either take this perspective or you don't. Right. The fact is, whether you all know it, which is why we wanted to have lots of real-world examples, is that the work that you do is in spite of all the challenges, right? When one of my teachers, one of my professors once said, two questions that tend to be pretty productive when you're approaching understanding how this messy stuff all works. And I mean, really, you know, all up and down all different scales, complexity, blah, blah, blah. What makes this job difficult? What makes them good at it? There's an implicit assumption that they are. And the fact of the matter is they are. There's always an opportunity for people to be worse at what they're doing. In which case, become curious about what makes it such that they are not nearly as bad at this as they could be. If you can identify that, when there's a deluge of alert overload and alert fatigue, like I said, in software we love to think of ourselves as we're so special and everything good in the world came from software, blah, 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 right? No, that's not true whatsoever. False alarms happen literally in every important domain. Otherwise, they wouldn't have alerts. It's an unsolvable problem. Unsolvable. There will always be false positives, especially for successful organizations. So to sort of scope in that way, one way would be to scope what are all the situations that makes it such that we can't make progress on getting this huge, noisy alerting shit, handle. Another way, angle, only different, not better or worse, is understanding that you can have a system, and you can design alerts and design systems that produce alerts that are, avalanches, and that come from another source other than we're not given time enough to work on it. Right? Sometimes that problem is so hard, it actually is really hard, even if the board of directors say, here's a blank check, go and fix the alerts. It still could take a lot of work. It's not just, I want the support and the buy-in on it. So looking at from different angles is sometimes really difficult. But starting slow, starting tiny little bits, I don't know. That's my probably not helpful answer.
Well, I think one of the things we were talking about as we were putting this slide deck together too is like the importance of sometimes just stating the obvious as well, right? Like, and we see this a lot when we're like working with organizations, it's sort of like, particularly around incidents, is like, well, what did you think was happening? And people are kind of reluctant to actually say what they thought was happening because they're like, it seems really evident to everyone in the room. And then someone will be like, well, I actually didn't know that it worked that way, or like, you know, and then all of a sudden it opens up this whole discussion about like, wait, you thought that? I thought that. And then so there's like this broader, you know, discussion that comes out of just sort of stating something that seemed quite obvious. I want to keep the conversation going, but I see people are leaving, so I wanted to put this slide up there just because these are a couple of resources, so, you know, take pictures or whatever.
The first one is a trick. It's a URL to a ridiculously huge number of references.
It is. That's probably like one of the most complete repos of this, but the Common Ground paper that I mentioned is in there as well, and it's definitely took hold within industry.
It's a must read.
Other questions or comments? Oh yeah, sorry, we got one here, one up front, Daniela.
Yeah, I was wondering if you could speak more to the difference between the joint cognitive system model where we were first working with like one machine and one human, and then at the beginning of the talk you mentioned multiple humans, multiple machines. It's a huge difference, and could you kind of just like reiterate like what the difference is, because we're all working in that kind of environment?
You're all, sorry, can you, the last part?
Just that that's the environment we're all working in.
Yeah, so when we were talking about that kind of joint activity and thinking about sort of cross-scale coordination and thinking about who and what is impacted, or who and what kind of needs information or can you get information from, it becomes less about kind of, I guess, handing off information from one party to the next, and more about sort of like we have this collection of skills and capabilities within an organization, within a team, whatever it is. How do we dynamically reconfigure those skills and capabilities to be able to meet the demands of the problems that we face? And I'll make a little distinction here because, you know, people are like, well, joint activity, isn't that just kind of like teamwork? And I think that there's a very fundamental difference, is that when we talk about teamwork, we're talking about groups of people that know each other, that have trained together, that like maybe have history on, you know, working on certain projects together. So they have what we call common ground. They have a basis to understand, I know what John knows about this world. I know what he believes about some of these theories. I have an understanding about like his orientation to different problems, and he has that same level of knowledge about my capabilities and my thoughts and my feelings. And that, when it comes to coordinative activity, is absolutely fundamental for these kind of smooth kinds of transitions. When we, just one second, we have, when we're talking about joint activity, it's often these ad hoc groupings, because you don't really know who you're gonna need at what points in time, and what sorts of like skill sets you might need to sort of bring to bear on those problems. And this is not just necessarily an incident response. This could be responding to a competitive threat in the market. It could be responding to an unanticipated, acquisition. How do you start working together with other, new teammates? And so when we're thinking about sort of designing these systems, we're thinking about how do we provide enough of a basis to be able to have that common ground or have that sort of knowledge, or to be able to really readily bridge that gap when you realize I don't actually know enough about what you know about the situation for us to work effectively together. And so part of that, like we could give a whole talk about that, maybe we should next time, is part of that is sort of like how we design the system. Part of that comes back to what we were just talking about of stating the obvious, right? One of my favorite things to do is be like, what kind of assumptions are we actually making here? Because what the mental model that I have about what we're doing, how we're doing it, and how important it is going to be very different from your mental model. And if we have good common ground, good basis, we're kind of in a well-structured joint activity, that'll be like a smaller gap. But as we move along and as we approach novel problems that we weren't sure we were going to face, that gap is going to extend. And so it's this kind of continuous reconfiguration. Yeah, I could go on about that.
The only thing I was going to add to what Laura was saying on your, a shift between, one person, one machine to many people, many machines. It occurred to me, the quip about regular expressions. If I will adjust it a little bit. Some people, when looking to solve a problem with responding to incidents, may think, oh, we'll add more people. Now they have two problems. And the coordination, the thing that is absolutely mind-blowing about Dr. Maguire's dissertation is stuff that is almost entirely invisible to us, especially teams that do this really well. But if we're working and trying to understand what's happening, and an incident commander or somebody says, "Oh, you want to go? Can you go check out the database now?" And you go, and then Laura goes off to check out the database, and then I'm doing other things. All of a sudden, I now have a thing, and she has a thing that is in addition to figuring out what the problem is. I have to remember that Laura went off to go check on something that is on my stack, right? If I don't hear back from her, that might mean a bunch of different things. Especially if I don't hear back from her in some expected period of time. If she has to remember whatever she finds, let's say she goes and actually everything looks normal, she has to remember to report back on that she found it normal. She might, depending on how many other people are responding, might have to explain what she did to work out what was normal. So all of these are paradoxical dilemmas and trade-offs that increase, or not just increase, become more complex as more and different layers, right? And we could expand on all those sorts of things, but.
Sometimes it almost seems a little bit silly, that example of like, oh, she has to remember to come back and tell us. But again, it's like we're sitting in a nice quiet room in a very theoretical, situation. We're not in the middle of a high pressure, like the system is down, and people are freaking out. You're getting emails from the VP, someone is like at an airport trying to log on to Wi-Fi, so it's like there's all these like multiple demands on your attention. And so again, this stuff matters in real world work. The types of like friction that can be inherent in that coordination matters as the time pressure goes up, as the complexity goes up, and as the consequences for getting it wrong go up. And I think the Boeing example is an excellent one of that. You have a machine agent who is flying the plane in a way that doesn't make sense for that moment in flight, right? It's like, why would you push the nose down when you're on takeoff? And so then you are starting to like, what are the signals that are available to the pilots in that moment? How much time do they actually have to gather new information about what's going on and what appropriate action might look like in that context? So yeah, I kind of keep coming back to this idea, like the more we understand about this in lower consequence kind of situations, the more that we can actually start to extrapolate and say, oh, these are general patterns about how people work with machines in these kinds of worlds. Yeah. There was, I think, another one back there. Yeah.
I'm curious, I feel like all of the examples of like joint actors were kind of on the same side, and I'm wondering if that extends to like adversarial actors in joint activity, if that's something that's considered, or what that relationship means, or how you think about it.
Nice, excellent. How much time do we have? I think you might be right. So might be a couple of ways. So they are engaged in a joint activity. they may or may not, in as much as they're both aware that they're engaged in joint activity. The Common Ground and Coordination and Joint Activity paper actually does a really good example of that. People who are opposed, people who are arguing, are engaged in joint activity, in as much as they both sign up to what the authors call the basic compact, which is they are both committed to continuing the argument, right? Even if their purposes aren't aligned. So the other thing is that there's a couple ways of spinning this, but one way to think about it is an adversary doesn't come after people if they don't think they're going to get any value from it. So to the extent that the target signals that there is something valuable to go attack and go get, inadvertent or purposefully, you could say that this is signaling, and that signaling is being hijacked for a self-centered purpose. That's one way of saying it. Both on the attacker side, you could see that attack, if there's, very rarely is there a single attacker, but sometimes there's a group of actors that are part of, they absolutely, as far as they're concerned, are hoping that they have fluid, successful joint activity, as well as the the defenders team. At the risk of assigning yet more reading, one of the couple years before Laura finished her PhD at the same lab at Ohio State University, a man named Matthew Brandlat wrote his dissertation on exactly this same topic, on adversarial, activities. And in that case was, in your straightforward sort of open-ended red team, blue team scenarios. So yeah, that's the short answer.
Yeah, I think it's a fascinating problem. And I would say, we had an example up there of sort of like military operations, and, war has fundamentally changed, right? Like, it's not bad guys over here with guns facing this way and good guys over here with guns facing this way. It is more distributed. It's integrated into safe spaces, so it has changed the way, those kinds of teams coordinate, because it's no longer appropriate to have sort of really centralized command and control. Here's the plan, go out and enact the plan. It is much more, here's what we think we're going to see when we go into these spaces, but it becomes about being better at gathering, like sensing the world for cues that are sort of like, this is not what we expected to see, and then being able to, again, dynamically reconfigure that collection of people and the broader sort of platoon or network of people to be able to like face whatever kinds of threats and risks come up. And so I think like in some ways, like even if it's not an adversarial like attack, sometimes when systems go down and there are like cascading failures, there's very similar signatures to it as well, in that it's unexpected, it's emergent, like you're on the balls of your feet all the time, ready. You have to respond and adapt and just look for signals in the world about what's going on. Yeah, so it's a good question. Do we have one up here?
First off, thank you. It's been wonderful. I have more of a comment than a question. As a junior developer, I found it really poignant when you were expressing, as somebody gains expertise in a field, they begin to not understand how they know things.
Yeah.
And coming into the field, I think it's something that we're looking at like humans and computers interacting. But as senior developers get more senior, the more computer they become, to a sense. Right? So when you're interacting with or onboarding or writing documentation,
interacting with a senior is sort of like interacting with a very complicated like system.
Yeah.
And how to, you know, unload that cognitive dissonance or that difference between that like generational gap too.
Yeah.
Yep.
Yeah. Oh, excellent. A couple things come to mind, and studies of expertise sort of loom large on this front. So I think you're absolutely right, and also what an amazing time it is for you, in that you are given way greater latitude, at least socially, notionally, not knowing what sort of jerks you work with, to ask dumb questions. And the opportunity is usually, and just as a sort of almost certainly a gross overgeneralization, more often than not, engineers, especially, you know, highly tenured engineers, very experienced engineers, very rarely are people asking them to tell stories, and or even an opportunity to explain how they know what they know, even if they're incomplete in making that. And the reason for that is pretty simple. They're a senior engineer, which means that the organization wants to get as much senior out of them, so they tend to be very busy. So finding opportunities and capitalizing on those opportunities to tell stories or give descriptions about how this thing works, or how this thing is tricky, or how this thing used to be this other thing, and here's the rationale for why it is the way it is right now, all those sorts of things. Gary Klein, Robert Hoffman wrote an excellent paper called Seeing the Invisible, and they described this as vicarious learning. Incidents are an opportunity to provide people with expertise to tell stories that without the incident they wouldn't have had an opportunity to do so. It also, it doesn't really get too much resistance, because incidents, you have to do something. Incidents spark, nobody says, oh, we just had a big incident. And rarely would somebody say, oh, no, we're not learning from that. No, let's get on with it. I'm sure it's fine. You know, let's not spend any time. We're not gonna do anything in the wake of that incident. You can harness that and give them, they may say things that a huge number of people in the organization didn't know. Your opportunity as somebody who is either new to the field or even new to the company, nobody says, oh, get a load of this. Look at this one asking stupid questions. Nobody faults, because what the hell do you know? And like entertaining those, it's the middle layers that don't know what they don't know that unfortunately provides that barrier. I'm happy to talk more about it with you, but it's a very unique situation, and you won't always have this advantage, because you're going to be them. Huh?
Mess up a lot right now.
Yes.
Yes, yeah.
Yeah.
Yeah, I think, what was your name?
Bronan.
Bronan, yeah, thank you for the question, because this is the complex socio-technical systems track, right? And so we've been talking about people in systems, but I think, you know, what John pointed to in terms of like creating opportunities where some of this context actually gets shared as a way of like filling gaps in our mental model is really important. I don't also know that there is psychological safety in every organization for you to be able to ask those questions. So, you know, we have, in a lot of the work we do with companies, it is like turning it to those senior engineers and being like, state the obvious, you know, like, so you sort of distribute that ask, right? The thing I'll say about mental models that is, again, could be a whole other talk, that I think is really fascinating about your world is that everybody has a completely like incomplete model of what's actually going on in your system and how it actually works. It's partial and incomplete in some ways, and within your team, each of those ways is slightly different. And that's largely what keeps your system running, is because there's sort of like this overlapping like knowledge base. So you kind of draw from each other, what do I know, what do you know? But oftentimes when you have these kinds of learning reviews or these opportunities to talk about how the system works, you get the senior people getting really like, what, really, that? Like, man, I've been working on this for 6 or 7 years and I always thought it worked like this. And those are really rich opportunities that if as an organization, your understanding is engineers should have all the knowledge and it should be complete, and they're like faulty in some way if they don't know things, is just garbage. It doesn't work in this world. You are continuously changing. It's continuously dynamic. So the expectation should be that you don't know things and you're continually trying to patch those holes. And as an organization, as a team, you're continually creating these opportunities to patch those holes. Not, oh, this guy doesn't know what he's doing. So we are at time. We're totally happy to hang out, but we should vacate the room, I think, otherwise. Thank you so much. You guys have been a great audience. So.
Thank you.